All right, hello everybody. Hope you all are doing well. This is our Math 4 video on parents functions. We're going to go through 4 parent functions in this one, then we're going to make another video, and it'll be the other 3 that we're going to talk about in this course. So the very first one is our constant function. So the constant function is the one that we're going to use today is f of x equals 2. So all that means is anytime I input something, our output is going to be 2. So for my table that we're going to make over here, if I input a negative 2 into my function, I'm going to get out a 2. And that goes the same for negative 1, goes the same for 0, goes the same for all of these. So what my graph looks like, it just looks like a horizontal line that goes through the y-axis at 2. So then we have all those features of functions that we talked about. So domain is going to be from negative infinity to positive infinity. Remember, we put those parentheses because it doesn't reach all the way to infinity. Range, if you notice here, it doesn't go up or down. So my range is just going to be 2. And we'll put that in a set because it doesn't go up or down. Increasing doesn't apply. It doesn't decrease either. So that also doesn't apply. It's not increasing nor decreasing, so it's constant the whole time. So we're going to say from negative infinity to positive infinity. All right, then we also have our minimums and maximums. For this, since it's a flat line, it doesn't go up or down. It doesn't have any minimums. It doesn't have any maximums. So basically, these will not be applicable the whole way down. So don't have any minimums, don't have any maximums. So that is our constant function. Next up, we have our linear function. I'm sure you guys have seen that before. But we're just going to talk about the basic one, f of x equals x. So that's like y equals x. So if I substitute in a negative 2 into my equation, I'm going to get out a negative 2. If I substitute in a negative 1, get out a negative 1, 0, 1, and 2. So it looks like that. So that's my table. If I go over here to graph it, I go to negative 2, 2, negative 1, 1, 0. Plot all those points, and then for our line we connect all of those because it is continuous. So talk about our domain. It goes forever from the negative left to the positive right. So we're going from negative infinity to positive infinity. Range goes the same way because it's going all the way down, all the way up, negative infinity to positive infinity. It is increasing across the entire graph. So we're going up, so at negative infinity, positive infinity, it does not decrease and it is not constant. So constant here just means that it's flat, just like that first equation. And then maximum, if you think about it, it keeps on going up forever. So there's no maximum, and it keeps on going down forever. So there's no maximum. Those are both infinity. So this does not apply for our linear function either. Next up, we have our quadratic function. So our quadratic function is f of x equals x squared. So that means whenever I input a number, I'm going to square it by multiplying it by itself. So that means I'm going to substitute in negative 2. That means negative 2 times negative 2 is going to make it 4. Negative 1 times negative 1 is 1. 0 times 0 is 0. 1 times 1 is 1. And 4. So we have this. So we go ahead and plot it on our graph. Negative 1, 0, 1. So we graph our nice parabola. Looks like that. It goes up forever. So our domain, remember, it goes on forever in both directions. So it's going to go negative infinity to positive infinity. But our range is going to be a little bit different because it does have a minimum here. So we're going to go 0 to infinity. And we're going to use a bracket because it does include the origin right there. All right, it is increasing on this side of my graph. So think of it as it's symmetrical. So on the right there at my axis of symmetry. So that means we're increasing from 0 to infinity. We are decreasing from negative infinity to 0. And remember, we put parentheses because at this point it is not increasing nor decreasing, and it is not constant at any point. I don't know why I put parentheses there. Ignore that. All right. Local maximum, if you notice, it goes up forever in both directions. So it does not have a maximum, but it does have a minimum because it goes down, hits this point, and goes back up. It is actually the same. The local and the absolute are both going to be the same for this one. So we got 0, 0, and 0, 0. So that is our quadratic function. And then next up, our last one is the cubic function. So this is if I substitute in my input, I'm going to cube it. So if I substitute in a -2, I'm going to do -2 times -2 times -2, which gives me -8. That's going to give me -1, 0, 1, and 8. All right, so then we plot this point over here. So if I'm going -2, I got -8 here, there, there, and there. So kind of looks like an S. All right, so that is our cubic function. Our domain, it goes forever to the left and forever to the right. So our domain is -infinity to +infinity. Our range goes all the way down, all the way up. So our range is also -infinity to +infinity. It is increasing over the whole entire graph. Even here, it's constantly going up. So we're going to put from -infinity to +infinity. It is neither decreasing nor constant at any point. And then local maximums, it goes on forever up and on forever down. So we do not have any minimums or maximums for our cubic graph. And those are our first 4 parent functions.